notes are more. Okay, so this is our Ruyer reading group, continuing our reading of Cybernetics and the Origin of Information. We're still on this long supplementary chapter that is added to the second edition in 1967. A lot of this chapter is sort of going over some of the things that have arisen in the world of computers, information technology, etc. in the, I think, 9 years between the first and second editions, and sort of seeing to what extent these technological developments sort of change the picture that he presented in the first edition. And then I think he's also sort of like extending, sometimes with varying degrees of success, sort of projecting into the future how this sort of technological development will continue. So some of the points that he's made in this chapter, I think, have turned out to not be quite as accurate as some of the early, like the arguments in the first edition. So like there's a discussion of translation that we looked at a couple weeks ago, I think, where he's pretty skeptical. He's pretty skeptical about the possibility of a machine being able to translate text. And of course, anyone who's used DeepL, Google Translate, whatever, that we know today that you can actually make a decent automatic translation tool. It's probably like those tools are probably I would say probably about as good as a human translator who doesn't have like specific knowledge of the subject matter of the text. Like most of the errors that it still makes are things that are, you can understand that it's an error because you have knowledge of the text, but it's not like sort of a linguistically impossible reading of the original text. So I mean, he would probably still consider that this kind of problem of needing to have this knowledge of the subject matter is something that you could never really fully eliminate in making a machine translation tool that would sort of be able to understand the context and the background knowledge and so on that you need to avoid those kinds of errors. And that sort of assertion seems pretty plausible to me, but like the general skepticism towards machine translation obviously turned out to be not accurate. And I think some of the other ones he talks about are like I guess what we would call computer vision. So in his time in the 1950s, 1960s, there was already some there were some efforts towards developing computer vision systems. So like trying to have a computer recognize a letter in varying fonts, orientation, sizes, etc., which obviously a human who is familiar with the alphabet can do very easily. And then now, of course, you have optical character recognition built into most like PDF tools, and pretty good. Sometimes like weird fonts or something get messed up. You get like letters that are joined together and stuff like that. But overall, pretty good. But that was also like a pretty long process and not like an easy problem to solve. Like as I mentioned, it was already being addressed in the 1950s, 1960s, and it's only in like the early 2000s that you started having like pretty good optical character recognition widely available. I think like postal services were already using some sort of system like that earlier, but it's probably more specialized. In any case, these problems are more solvable, I guess, than he would have expected at the time he was writing, but also still required a lot of work, and they were not easy problems to solve. And I think it's also important and interesting that these kinds of problems generally, like to the extent that they are solved, were solved using machine learning techniques rather than sort of building in explicit rules or data structures that sort of encoded explicitly how to solve the problem. So it's not like someone sat down and told the computer, this is how you recognize a letter A in different fonts and orientations. It was more just like as a sort of simplification, just feeding in a bunch of examples of letters and labeling them either the letter A or not the letter A, and having the computer sort of extract from the training data, a very sort of abstract representation of what the letter A examples have in common, sort of in opposition to the non-letter A examples. And yeah, so a lot of these sort of machine learning processes, like once you actually train the system, it's kind of a black box. Like you can't actually, as a human, even the person who like is designing and running the system to train the machine learning process, you can't really say what it is that the computer is picking up on when it recognizes the letter A, or it's very difficult to do that. Often you have to like test it in various ways to say like is it capable of recognizing the letter A with this other property, whatever it is, and then that sort of tells you whether it's using that property to recognize the letter A. So yeah, so it's not just that we are not building the knowledge into the system explicitly, but also that we don't even know necessarily what it is exactly that the system is using to perform this recognition. We just sort of measure whether how successful it is on new data that it hasn't seen in the training, and then if it sort of meets your threshold for whatever task you're doing, then you say, okay, this is good enough, and we say this system is capable of recognizing letters. But we don't necessarily know how that was done. And so this is like one of the big sort of oppositions in different, I guess, strategies in AI research was like, do we sort of build in knowledge to the system, give it explicit rules or representations of whatever we want the system to be able to understand or manipulate or whatever, or do we sort of feed in data and let the system learn whatever it is we want it to sort of understand about the situation. And so there's been, obviously in the last 20 or so years, a big emphasis on the learning side, that this pretty much all AI research now is based on this kind of, feeding in data. There has been some, I think, skepticism about, how far that you can go with this, because like a lot of the sort of the leading models, ChatGPT type stuff, all those LLMs, they have been essentially trained on all the text on the internet at this point. There isn't really anything more to train them on, and they're clearly not like at a human level of competence at a lot of different things. Especially anything that requires like sort of step-by-step reasoning or operations or anything like that. They tend to mess those up pretty often. So clearly a human who is learning on a much smaller, set of inputs, and getting much better results is not like the human's learning process is much more efficient than whatever learning process is being used in these systems. So yeah, it seems like this sort of just feeding in a bunch of data, hoping you get like a good result at the end through this training. That model seems to be sort of running up against its limits at this point, and it seems like you probably need to have some kind of structure built in, or at least a different kind of structure, to sort of get beyond where things are now. And just maybe like a bit of an aside before we dive in is that so ChatGPT, the GPT-5 model was released I think this past week. And from the things I've read, it looks like it has a lot of the same limitations as earlier models. Like there's I think I might have posted it on here with an earlier model. Like I actually can't remember. Anyway, someone asked the ChatGPT to create an image of a bike with labels for all the parts, and like it's pretty funny to look at, because like you have like all the parts are mislabeled. They're like names that don't make sense. They aren't even words. And yeah, so and then so someone tried the same test with GPT-5, and it does basically the same thing. Like labels in the wrong places. Names that are not even words. Yeah, so this sort of like understanding structure and how parts fit together and how they're related to each other is like still a pretty difficult problem, and it doesn't seem like just feeding in more data is likely to lead to any, or like to much improvement on that. Maybe like incremental improvement, but like not getting even to the level of like a 6-year-old's understanding of a bike. Okay, so yeah, let's pick up from page 155 at the section break. Yeah, Angus, could you read that bit?
Yeah, no problem. So we're at the autonomy of semantimes, right?
Oh, sorry, I missed. Sorry, what did you just say?
We're on 157, right?
150. Oh, did I say? Yeah. Sorry, at patterns. Yes.
Okay, I think we did that one. I think we're on the autonomy of semantimes, but I'll just start from there. The autonomy of semantimes and the three types of continuity. Unintentionally and despite its mechanist tendencies, cybernetics will have thus contributed to the introduction of the notion, which is widely accepted today in many fields, of the autonomy of meanings, of patterns as products of meanings, called quote-unquote semantimes, or quote-unquote semantic gen identities. This notion is very revolutionary in relation to classical science, and the comparison is very illuminating. Naive physics of ancient atomists or early 17th century mechanists believed only in the reality and temporal continuity of matter. Then, energetic physics defined another type of reality and temporal continuity, energy. When ball A hits ball B, it's not just the physical balls that are conserved, it's the motion and kinetic energy that transfer from one physical quote-unquote support to another at the moment of impact. A wave is just as real as a piece of matter. It has a temporal continuity, a formal gen identity, just like its quote-unquote support, the string or the molecules of water. Then we perceive that energy, or the formal gen identities, could be primary and autonomous and surpass material support. A field of electromagnetic or gravitational energy has no need of ether. It is a sort of matter energy in space-time. George Gamow said that it is like a snake, which transports its wave movements with it. An atom called material is a system of waves, and it would be vain to search for a submatter as a support for these waves. Yet patterns and semantimes represent a third space of continuity. A word, for example, does not owe its temporal consistency to its matter or its form. If it is passed from mouth to mouth or from dictionary to dictionary, this is not as a wave. It owes its consistency to its meaning, of which it is the carrier symbol, the formal support. The relation is quite free, moreover, since words change meanings and meanings change words. The same as wave energy is most often tied to a material support, but can also be detached. A semanteme is tied to the form of an information support, but it can also be detached. In translation, the non-mechanical translator reconstitutes the meaning in order to pass from one support to another. In communication, which is the reverse, the emitter passes from meaning to a support, as the receiver passes from this support and its negentropy information to meaning. We search for words in order to express our thoughts. In the history of culture, what interests the historian are ideas, themes, schemas, or patterns of institutions or of techniques, and the like. Thematic and semantic continuities, while resembling material and formal continuities, have a very peculiar character, at least at first sight. They seem to be independent of space and time. They seem to be able to enter and exit them. An idea can be lost, rediscovered, then lost again. This is either because its support remains without being understood and is then understood again, or because, if all support is lost, the idea is reinvented. One can pick up a problem again, or forget it, or leave it aside, and take up something new. One can also resume a learning process in progress after having done something else in the meantime. You see, yeah, I guess I'll just finish the section. Is this independence with respect to space only an appearance? We here touch on what is probably the essential division between two rival and irreducible interpretations, not only of cybernetics, but of philosophy and of science. 1. We can refuse to admit that meaning and semantimes are really detachable from space-time, and consider any such conception as mythological. It is then necessary to admit that the idea, the meaning, when it seems to be quote-unquote lost, is pictured in the material brain, or in some auxiliary mechanical supports of the cerebral memory. This amounts to considering the semantic continuities as fundamentally illusory by reducing them to the material or formal continuities. We can frankly admit this autonomy with regard to space-time. This is option 2. This is what we have done by considering mechanical feedbacks and materialized quote-unquote controls as only limited and degenerate forms of ideal feedback and control. Cofignol who nevertheless remains quote-unquote spatialist, is not very far from this conception when considering quote-unquote mentality as a sort of information assimilation function, since this comparison suggests that the semantimes are autonomous and can be detached from their support. It seems to us that science since 1945 has itself made a number of steps in this direction. Not only the human sciences, which have always postulated the autonomy of ideas without always admitting to this postulate, but even the physical sciences. They are today a lot more attached to the conservative principles in space-time, even for matter-energy, which authorizes the same detachment a fortiori for semantimes. If energy is conserved, negentropy is not conserved. We have known it since Carnot and Boltzmann, and Bonsac has emphasized it again vigorously. Carnot's principle implies that something leaves the world. On the other hand, according to Fred Hoyle, we must admit a continual creation of matter, which thus appears in space or creates supplementary space of some sort, since the average density of the cosmos is constant, the expansion counterbalancing the creation. We do not then see what would be mythological about admitting for the semantimes what all physicists admit for negentropy and some for matter. If there is some mythology, it is rather in the arbitrary postulate that supposes without any proof that all subsistence of meaning is always fundamentally material memory. This postulate is even more inadmissible since, for contemporary physics, the material persistence of a mechanical memory is itself, like all that is material, the persistence of a wave system. If our unconscious ideas persist, quote-unquote, engraved in the cerebral proteins, these proteins are, like all molecules, only wave systems. The notion of quote-unquote engraving only has meaning for phenomena on our scale. Is it necessary then to admit that these wave systems are in turn quote-unquote engraved in a submatter? Physics has abandoned the old theory of the persistence of ideas as quote-unquote engraved in matter is no more justified than the theory of considered as an indispensable material support for light waves. Yeah, it's an interesting comparison that the meaning of a text is not reducible to the negentropy of its material support, in the same way that subatomic phenomena are not, or I guess I should say, not all like wave phenomena is a wave in something like a medium, like the luminiferous ether, and that it's not always the case that we can find submatter in which there is this kind of trans-temporal identity. And I guess the point about Fred Hoyle and Carnot seems to be that there are these scientific laws that hold, for instance, the idea that the density of the universe, I think the idea is the density of the universe is constant even if the universe is constantly expanding, which means that matter is constantly created. So there's this principle or this this kind of rule that is not just a description of the behavior of matter, but it is more fundamental than the matter itself, since it describes how matter itself is created as the universe is expanding, something along those lines.
Yeah, so just to explain a little bit some of the background that Ruyer is like alluding to here is so you have in I guess like the mid 19th century. Sorry, let me go back a little bit further. So in the 17th, 18th century, there were sort of two competing theories of light that were adopted by different physicists or natural philosophers, I guess as they would have been called at the time. And so you had the wave theory and the particle theory. So Newton thought that light was made up of little light particles, and then Huygens and people like him were thought that light was a wave of some kind. And both of these theories had there were things that they explained well, and then there were other things that were sort of hard to explain on each account. And one of the sort of big questions for the wave theory of light is, if you can see waves in water, if sound is a wave in air, then what is light a wave in? It's not that clear what exactly that would be. and there was sort of back and forth between which of these theories is the better one. But in the mid 19th century, you have Maxwell, who sort of identifies light with with waves in electromagnetic fields. That there's like, anyway, not going to go into all the details, but you can sort of unify the theory of electromagnetism with the theory of light, and so this was like a very powerful unification in physics, and gave a lot of support to the wave theory of light. But you're still left again with this question, what exactly is undulating in this wave theory of light? And So Maxwell had this sort of mechanical model that he had presented. I don't think he ever said like this is like the real way the world works. It was just sort of like I guess like an analogy for understanding the way a light wave would propagate. But Yeah, many physicists in the 19th century assumed that light was, given that light is a wave, it has to be a wave in something, and so that something, we're going to call it the luminiferous ether. And so this is some sort of substance that pervades the universe, that light waves are a disturbance of. And then, of course, you start getting these sort of weird results with, well, for one thing, the fact that the speed of light in a vacuum is constant. Even like there's the famous Michelson-Morley experiment where you're looking at the speed of light relative to the orbit of the Earth around the sun. And so if you're thinking of like normal speeds, then you should be able to detect a difference in the speed of light in depending on whether it's sort of adding to the speed of the Earth or orthogonal to the rotation of the Earth. And it turned out that there was no observable difference. So the velocities were not adding in the way that you would expect, and so the speed of light is constant rather than sort of changing depending on how fast the object is moving. And of course, this kind of problem eventually leads to Einstein's theory of special relativity, and the sort of general interpretation is that this kind of eliminates the need for anything like a luminiferous ether, and so you just have waves that are just sort of in this ambient electromagnetic field and are not waves of something, like they're not in some kind of substance in the way that a sound wave is a wave in air. And so Ruyer is kind of using this as an analogy when he's talking about these, semantemes or meanings or these kind of ideal forms. So we clearly have, a meaning is something that can be sort of moved around in different ways. Something like, you can talk on the phone to a friend, and something, some information that you have about, I don't know, what the weather is like where you are, you can transmit that information to this other person on the other side of the world. And so this sort of meaning, the temperature here is X, say like this proposition. So you sort of formulate it in words, and you disturb the airwaves. You disturb the air. Next to your mouth, you have sound waves that are leaving your mouth, and that causes a diaphragm in the phone. Or I'm using sort of old telephone technology here, but yeah, you cause the diaphragm to vibrate, and that gets turned into electrical signals, etc. So you have like, there's no sort of single physical property that is conserved along this whole operation. You have sound waves turning into electrical signals, and then back into sound waves. But this sort of proposition, this semantic structure, is being transmitted from one side of the world to the other. So clearly there's something that can be, conserved across this communication operation. And then the question is, do we have to sort of assume that there's like some bearer of this semantic structure, that this sort of proposition, the temperature is 25 degrees Celsius or whatever, does this proposition have to be sort of implemented or realized in some substance that bears it? And so Ruyer, of course, is going to argue that it doesn't, that we can treat this semantic structure as kind of freestanding. And then, of course, for us to interact with this semantic structure, of course, requires us to to be connected to some physical realization of the semantic structure. So like a sound wave that conveys someone's voice or whatever it is, but that doesn't mean that the proposition itself is sort of dependent on the sound wave or the ink on paper or whatever it is that expresses the proposition. So this is sort of like the analogy that he's presenting here. So just as a sound wave, or just as a light wave doesn't depend on a sort of bearer, an ether in which the wave would be a disturbance. Likewise, we don't have to assume that semantic structures, meanings, and so on require a bearer. And even ultimately, like when we think about like what this bearer would be, so if we think of some sort of material or matter, the sort of order of fundamentality in physics is kind of reverse of what we might expect from a more common sense perspective, because particles like electrons, photons, whatever, are in contemporary physics treated as wave packets. So they're like a particle is a certain form of a wave and not a certain arrangement of particles forming a wave. So that the waves are more fundamental to compared to the particles. So again, we don't have any. So this is all just sort of meant to, I guess, loosen our, I guess, presupposition that a semantic structure would have to be realized in some material arrangement of elements. That's the only way that a semantic structure could exist. Okay, so we can go on to the next one. I can read this bit. The double coherence of machines and organisms. The autonomy of semantemes appears clearly in what we can call the double coherence of machines. 1. A machine is materially solid if it is well constructed. However, after being damaged, it is destined to rust and finally to go to the cemetery for old scrap metal, unless by some chance it goes to the Musée des Arts et Métiers. 2. But a machine, as a technical type, also has another coherence. It appears in the history of culture. It derives from another machine. It is reproduced and perfected. I wonder if he's thinking of Simondon here. Anyway, sorry, that's an aside. Okay. We sometimes say of a technical conception that it is quote-unquote solid. The history of machines is not the history of millions of assemblages of pieces of wood or metal. It is the history of technical ideas. A being of the macroscopic visible world only has a single sort of coherence. The degradation of a mountainous system, of a river or a rock, is irreversible. A used machine, however, can be repaired or replaced by another of the same type. The, quote, second coherence, unquote, of the machine is, of course, borrowed from the human organism. It is the human being who invents, maintains, repairs, reproduces, and progressively perfects it according to his ideas. In general, however, every organism possesses a, quote unquote, double coherence by itself. Each individual, as fully, quote unquote, solid as he is destined to die. There are cemeteries for humans just as there are for automobiles. But the animal or the man persists a lot longer as a species by passing from individual support to individual support. The individual lends to the machine his own coherence, his quote-unquote typical or quote-unquote ideal immortality. Even if it is materially solid, without man, the machine would obviously only be able to degrade like a rock. We clearly see the absurdity not only of understanding man through the machine, but of resorting to the material solidity of his brain or of cerebral proteins in order to explain the solidity typical of man and his ideas, the source of the solidity, quote-unquote, typical of the machine. Moreover, embryogenesis directly demonstrates that the brain is remade for each individual. All that remains for the materialist interpretation, then, is the resource of putting the continuity of organisms in the matter form of genetic proteins, which in each embryogenesis would rebuild an individual organism with its brain and pre-existing cerebral memories, like micro-machines with programming and feedback. The double coherence of the organism would thus, strangely, be based on the simple coherence of its material reality. It is actually more rational to explain the double coherence of the living organism by the fact that it is a mixture of three modes of continuity: the material, the formal, and the semantic. The autonomy of the semantemes assures the typical continuity of man first, and indirectly the machines that he constructs. The visible organism participates with some unobservable semantemes. Right, so this is again this idea of transmission of a form or a semantic structure and so on. So like in the case of the machine, so you have say two instances of the same model of car. Here you have like a sort of design or this intellectual structure saying where all the parts are and how they relate to each other and so on. Again, the kind of thing that ChatGPT is not awesome at understanding. This kind of arrangement of all the parts, like a sort of abstract blueprint, is something that can be repeated in many copies. And then that abstract blueprint is what is sort of modified as the design of that car develops from say like the Model T to like more modern cars. So it's not that you just like sort of take a concrete instance of a Model T, this specific chunk of metal and put together in this specific way. You don't take that car and then add and remove and tinker with that specific car to get to I don't know a Tesla or whatever. It's this sort of abstract design of the car that is sort of modified in this kind of abstract semantic world, and then each of these iterations of this modification gets realized in concrete cars that are produced in a factory and end up in a scrap heap somewhere. And this, of course, is different than in the case of living beings, where an organism is capable of reproducing a subsequent organism that has sort of the general, again, this sort of abstract blueprint in common with its parents. But it's like the organism it reproduces not only this sort of, it has a sort of double reproduction. It produces a concrete instance. It produces this specific offspring, but it's also sort of reproducing this abstract blueprint at the same time. Whereas in the case of the car or other technical objects, those are sort of two separate operations, where you have like this abstract blueprint and how that can be modified over time, and then you have the production process in which that abstract blueprint is realized in a concrete car. In the case of living organisms, those two processes are the same. You as you reproduce, you are both producing an individual organism and an instance of the species. And so the question again is like, do we have to assume that there is some sort of underlying material continuity in that reproduction process, that there's some sort of individual molecule, like he's talking about like a sort of genetic interpretation. There's one molecule or one collection of molecules that is sort of materially identical from parent to offspring, and this is sort of what underlies the this sort of abstract continuity of the organism from one generation to the next. And this gets into all the things about embryogenesis that he's talked about a lot throughout this book. But he's of course thinks that this is a sort of illusion that you can explain the development of an organism just based on this sort of abstract, or sorry, this sort of static molecule. Like in a contemporary context, like just a piece of DNA would sort of explain the whole organism. So the organism has this double coherence, and then the simple coherence of the machine is explained through that. It's only because there are living organisms that have this self-reproducing property that there can be machines that don't have that self-reproducing property, and not the other way around. Okay, so we can go on to the next bit. Would someone else like to read from page 160, The Problem of Copies?
I can read again if nobody else wants to read. The problem of copies. The autonomy of semantemes with regard to space-time is the key to the indefinite persistence of living forms, which, unlike the structures of the physical, do not get lost, at least in their type, in the, quote, background noise, unquote, that overwhelms everything. Contrary to appearances, it is also, first and foremost, what ensures the very multiplication of forms. For Léon, pronounce that, Brillouin, I'm just going to call him Brillouin, information, or in general form, on the one hand, degrades according to a generalized form of Carnot's principle, and on the other hand, it can be multiplied by copying, quote unquote, pedagogical transmission, and so on. A warm body loses its warmth as it passes to a colder body with loss of neg entropy. Pierre, an informed man, passes information to Paul, who, in receiving at least some of it, in general degrades it a little. The difference with the first case is that Pierre has lost nothing by communicating his knowledge. A professor teaches the Pythagorean table to his 30 students. Each student remembers, or quote unquote gets, half of the table. The information has then been multiplied by 16, one for the professor, who always knows his table, and 15 for the students. There is a multiplication of information, although the principles of physics are satisfied by a degradation through the process. Moreover, according to Brillouin, the two phenomena, degradation and multiplication, are linked. There is a sort of compensation. The multiplication, the creation of order in the receiver, must be paid for by a consumption of neg entropy. When a book is printed in 10,000 copies, each copy represents the same information as the manuscript, but neg entropy was required to operate the printing presses, and each reading requires some expenditure of light or cerebral metabolism. Bonsac sees things quite differently. He maintains against Brillouin that the increase of information is only apparent. The cases of information of the teacher and of the students are not independent. They come from the same source and are linked together. Even if we add the information possessed by the teacher to the information acquired by the students, the total information does not exceed that of the teacher. In the case of a retransmitted message, according to physics, the original always degrades. In the same way, every time a form is communicated, there is an echo effect, like a multiplication in mirrors. Between two parallel mirrors, an object appears multiplied to infinity, but is the information multiplied or increased? We can always carve out a, quote, path of transmission, unquote, of a form or of some information by as many segments as we like, and declare that each segment then multiplies the information. We can place a radio or television receiver in each cubic meter around the post of the emitter. I can theoretically place my eyes at any point in space and have a copy of the landscape. The physical images of an object are only ever the displaced and degraded form of this object. The division is arbitrary. From the point of view of physical reality, there is only a global phenomenon of extension, degradation. Cutting into slices by receiving mirrors or by any kind of detector multiplies nothing. There is a true multiplication of information because the students or the living and conscious readers are not the same as mirrors or receiving apparatuses placed in the path of a flow of information in the process of degradation. In fact, the students can not only lose a lot less than 50% of the lesson of the teacher, but they can lose nothing at all. And if they are more intelligent, then they can even improve and develop his ideas. Yeah, I don't totally understand the application of the autonomy of semantiums to these two positions. The first being that, well, I guess the idea is maybe that even if the sort of physical transmission of the information's material support is always compensated by a loss of, or always compensated by an increase in entropy, that can be true of the material support, but it can also be the case that there is a kind of creation of information at the level of the semantium, which Ruyer wants to kind of place outside of space and time, or in the survey of the consciousness of students in the example of the mathematical theorem. And this also explains how we can kind of get around Bonsac's objection, which is that we can kind of arbitrarily carve up the transmission process of some, item of information and claim that it is multiplied across, any like arbitrarily small section of that process, which doesn't really make any sense to say that, in some like infinitesimally small slice of like the sound waves that I'm producing, information is being increased. But maybe Ruyer is saying that we can admit that there isn't this kind of infinite increase in information in the material support, and acknowledge Bonsak's point, and still claim that information does increase because it's a matter of the grasp or transmission of the semantiums.
Yeah, I think this passage is a little bit compressed. It's there's like several different positions that he's kind of going through here in a couple of paragraphs, and maybe not making things easy for the reader to see what each of these positions are. So so I guess you're starting with the question of what is going on with the sort of quantity of information in these instances of reproduction or copying. So in the case of the teacher who is conveying the multiplication table to the students, you have so in one way of looking at this situation would be that you have one copy of the multiplication table in the mind/brain of the teacher at the outset of this teaching operation, and then at the end of the teaching operation, each of the students has the same multiplication table. So you've multiplied the information by 30 or whatever, or in his example, if the students forget half of the table after the lesson, if each student forgets half the table at the end of the lesson, then you have like 15 times the information rather than 30. And then I guess the objection to this sort of maybe naive way of looking at the quantity of information would be that if you sort of expand your scope of what you're counting as part of this system that is bringing about this reproduction of information, then you actually find that there's always a diminution, a decrease in the amount of information. So in the case of the teaching, of course, the teacher has to expend energy to recite the multiplication table. There are chemical bonds that the teacher has absorbed through digesting food that are stored up in his or her body, and then to move the muscles and so on to be able to produce the sounds, the teacher has to break down those chemical bonds and release energy. And so this is a sort of degradation of the neg entropy that was stored up in those chemical bonds. And then likewise, the students are, I don't know, taking notes in their notebook or whatever, so they're moving their muscles and breaking down chemical bonds as well. So if you sort of take the whole situation into account, and all the breaking down of chemical bonds that happens over the course of this learning, of the lesson in the class, you find that the entropy is actually increased rather than decreased. A lot of this neg entropy that was stored up in those bonds has just been released as heat, which is like a sort of disordered state of the world. And likewise, if you have any sort of mechanical reproduction, like printing a book, of course the machine that is doing the printing also releases heat, etc. So again, you're taking some sort of stored energy. It could be chemical energy if the electricity that is running the machine, it comes from a coal or natural gas power plant, or some sort of stored form of energy is being released is being sort of degraded to power this machine that is reproducing the book with the multiplication table or whatever it is. So again, in this situation, you start with this more structured, lower entropy situation, and at the end you have a less structured, higher entropy situation. So it's only this sort of partial perspective where you only look at the sort of like very limited aspect of the situation of how many copies of the multiplication table are there, that it seems like there's more information, but in reality, when you sort of take everything into account, there's less information. So this is sort of like the second position in this sort of chain of argument in this passage. And then the sort of objection to the objection, the sort of third step in this argument is, the second stage kind of relies on the idea that you can identify the the reproduction, the instances of reproduction or instances of copying that are happening. You can say that, X number of books were printed, X number of students learned the multiplication table, etc. But this seems to be like, if you look at other situations, I mean, in the case of printing books, there's an obvious sort of unit, like the single copy of a printed book is an obvious unit to use. But in other situations, the sort of unit is arbitrary, and so he talks about, like, say, a radio transmitter. So the radio transmitter is disseminating waves out in a sort of spherical pattern around that transmitter, and you can detect those radio waves at any point within a certain distance of that transmitter, and so you could, surround the transmitter with receivers, every meter, like in any direction around the transmitter, you set up a receiver, and so you have, I don't know, millions of copies of the originally transmitted message being reproduced at each point. And you can imagine, I mean, obviously in reality, a receiver has to have a certain volume, but this is just sort of like a technical obstacle. You can sort of imagine the receivers being smaller and smaller, and more and more densely packed around the transmitter. So it seems like you can have as many copies of this radio wave of the original radio transmission being produced as you want, depending on like how fine of a grain you apply to the situation. And so depending on where you actually have the receivers in the situation, like where, at what point, how many receivers there are, where they're placed, etc., you can get different answers for like how much information is being produced or lost or whatever. So in this case, so what Ruyer wants to insist on here is that the case of the receivers who are, the receivers that are sort of arbitrarily arbitrarily many receivers copying the original transmission is different from the case of the students, because the radio receiver is not grasping a semantic structure, is not grasping an idea or anything like that. So the receiver will reproduce just some random sequence of sounds or static or whatever, just as faithfully as it will a news report or a poem or a piece of music, whatever, that actually has some sort of meaning to a human. The receiver doesn't care whether the signal that it's reproducing is meaningful or just random gibberish. It is just sort of copying it through this electromagnetic, through the circuits and how they operate within the receiver. Whereas the student who is learning the multiplication table, I mean, I guess this is not like a great example of this, but the student has to have some sort of understanding of what a multiplication table is, what you use it for, etc., and sort of grasp it. And then, students will sometimes sort of detect patterns in the multiplication table that maybe the teacher didn't explicitly convey to them. So they're sort of getting more out of the structure that they are reproducing than was directly conveyed to them. So in this case, it's not just that the student is sort of mechanically reproducing this pattern that was transmitted, but they are sort of using that pattern to grasp a semantic structure or to grasp an idea, and they can take that idea and develop it further in a way that a radio receiver obviously can't. So that this for him, this is why we have to sort of distinguish these two situations where the radio receiver is not producing more information, whereas the students in the classroom who are learning are producing more information. Okay, go on to the next one. Probably only have time for one more reading, I think. Yeah, so this one is a bit longer, but yeah, I can read the next one. Consciousness as information support. The sensations of living beings as phenomena that are first of all physiological can be degraded images. But when they become perception, that is, psychological information of which the support is the field of consciousness, meaning is reasserted in its autonomy. This is what the physiologists, after the psychologists, are discovering today. Naturally, they are doing so in their own way by opposing the eye or the ear, not to the active consciousness that understands their signals, but to the brain. Speaking of the brain as a material apparatus that performs the decoding of signals, Entirely in keeping with their postulates, they in fact make it perform as if it were a mind, esprit, that makes hypotheses, trial and errors, reasons by implication, and hesitates if it does not have sufficient clues to draw a conclusion. It is not the first time in the history of the sciences that out of concern for positivity, we fall into a magical conception worse than the one we wanted to avoid. Without attributing magical powers to the brain, let us instead directly examine the particular properties of consciousness as information support. Rather than a consciousness, quote, a consciousness, unquote, which risks being construed as a mythical personification, consider a field of consciousness. For example, a visual field, when sensation, having ceased to be a physical image in the physical space of waves and photons, has become a quote-unquote subjective image, but is not yet perception. According to Gregory, the eye supplies, quote, coded information, unquote, to the brain. Quote, we may take an analogy from written language. The letters and words on this page have certain meanings to those who know the language. They affect the reader's brain appropriately, but they are not pictures. No internal picture is involved, unquote. This thesis mixes truth and falsehood. The true part is that the conscious visual field, whether obtained already at the level of retina, only of the occipitals at an intermediary level, does not need to be looked at. It is, as we have often emphasized, a quote absolute surface, unquote. That is a quote-unquote surface that is non-geometrical, a quote-unquote surface subject, which has no need of a point of perspective in a third dimension. However, it is false that the brain, or consciousness, somehow decodes the information of perception and forms the idea of the object sensation. This would be to return to the conception of consciousness facing the object sensation. The visual field of consciousness is an absolute and informed presence before being secondarily interpreted according to all the themes and semantemes of the psychic organism. This next bit is in small type. I think this might be like an addition or something. I can't remember what the small type indicates here. Okay. Gregory sees the beginnings of a proof of his theory of coding in the recent discoveries of the physiologists David H. Hubel and Torsten Wiesel. By presenting a cat with some quote-unquote prepared bars of light from various angles, they record in its brain some discharges of certain cells when the bar is in a certain orientation, and a different cells when the orientation is different. Some different cells, yet again, are activated when there is a movement of stimulus in certain directions. Gregory concludes that there is no cerebral image, but only some coded combinations of cellular activities. It is probable that there are some selective cellular analyzers of this type. Color vision implies them, as does the sensation of movement in the periphery of the visual field without consciousness of a definite object. It is the same in hearing, where high and low notes are more finely analyzed than by the best physical receivers. However, we do not see why that would contradict the intuitively hard-to-reject notion of the overall field of sensation with patterns and sequences, forms, and melodies which are immediately expressive, if not meaningful or useful. The field from which certain elements are specifically selected according to particular subordinate analyzers. B. It's this character of the field of consciousness of being a quote-unquote subject surface which makes it an information support that has no analogy in the 1. The passage from a physical support to a conscious support for a form or piece of information produces some very particular effects. At the extreme, the conscious support can give a meaning or an expressiveness, that is, a semantics in the broad sense, to a physical form that doesn't have any. Consciousness transforms all form and even all appearance of form into information. It quote-unquote reads as a text even what is not a text. This fact has been of crucial importance in the history of humanity and even in the history of life. Animals also quote-unquote read. They too create false meanings, but only according to their instincts. Man sees quote-unquote meaning everywhere, even in the physical, in constellations, mountains and oceans, cataclysms and seasons, droughts and floods, as well as in the episodes of its life and those of other living beings. This is not, by the way, purely an illusion. Physical phenomena certainly have an inauspicious or favorable meaning for him. We understand that he is on the lookout for warning signs. The mistake is only in confusing the scowl of nature with the scowl of another human being. The reading of physical phenomena can even become scientific when the phenomena are channeled into derivation so that it can be recorded by instruments such as the barometer, seismograph, or other recording device. Couffignal has proposed that we should consider such instruments as creators of information. But the information is only created when it is read. The decreases of barometers by themselves are part of the physical storm in the same way that unperceived physical images of the sun are part of the sun. Measuring and recording devices are only tools of perception. 2. The field of consciousness as a surface subject allows true conditioning or learning, not just their simulation. Contrary to the theses of Gray-Walter and Dr. Sauvin, spatial and temporal overlapping of two stimuli, the absolute and the conditional, is not enough to produce true conditioning. It is necessary that the animal, quote unquote, notice this overlapping, and that it thus itself creates a true pattern made of meaning, where the configuration is indissolubly tied to the thematic motivation. It needs a true conceptualization as well as a true valuation. Gray Walter has since recognized, by the way, that conditioning and learning require an active, attentive, and selective patterning, which he naturally attributes to the brain in keeping with his postulate. Quote, it would be quite easy to make a computer-regulated autopilot for a car that would avoid obstacles and maintain an optimum speed, even in dense traffic, but to provide it with a visual recognition system that would distinguish red traffic lights from all other red lights, and would class them with the outstretched arm of a policeman, a halt sign, and other conditional signals. This would be a problem of a different order altogether. 3. The surface subject that is the field of consciousness allows invention because it is a sort of canvas for, quote, completion matrices, unquote, as in intelligence tests. If I see a set or series of forms, I can immediately notice their type or category. I can eliminate a form that stands out, put displaced forms in order, complete an incomplete series, fill in a blank, or invent the missing term from the perceived relationship. The printed material of a psychological matrix test clearly does not have any more tendency completed than a blank piece of paper has to cover itself with writing. Once transferred by perception to the field of consciousness as a universal canvas, the matrix has at least a chance of completing itself on its own. Of course, consciousness is often stupid. Through years for the individual and millions of years for the species, intelligent creation at the level of conscious perception, which is secondary in relation to the primary intelligent creation of the organisms themselves by themselves, has remained difficult, and the word, quote, immediate, unquote, hardly appears justified. It is nevertheless legitimate insofar as the intelligence of living beings comes directly from their consciousness. All animals, even inferior ones, spontaneously generalize and conceptualize. Machines behave, quote unquote, intelligently solely through their assembly, montage, without being conscious, whereas the intelligence of living beings is inherent to their consciousness. Their intelligent, quote unquote, setups, montage, for a detour, for example, come from their conscious, quote, point of view, unquote. So this idea of this like absolute surface is kind of like his central concept of his whole work, I think. And so in the case of like visual perception is where this is like most evident, I think. So I think we talked about this maybe in the Merleau-Ponty reading that, at one point in the psychology of visual perception, there was this sort of question of how the retinal image gets inverted. So if you look at the optically projected image on the back of a vertebrate's eye, the image is actually upside down compared to the world outside. So a tree, that the eye is pointing towards, the image of the tree on the retina at the back of the eye has the branches at the bottom and the base at the top. And then the question was, of course, when we look at the tree, we don't see the branches at the bottom and the base at the top. We see the tree, standing, in the normal orientation. And so how do we get this inverted retinal image to produce the sort of properly like non-inverted perception of the world? And this question already sort of presupposes that there's something looking at that retinal image, that there's like a little like an eye inside your brain that is looking at the image and then somehow has to figure out that this image is upside down and turn it right side up. But then obviously that doesn't really explain anything, because then that like micro eye in your brain would also have to have something else looking at its retina and presumably inverting its image or whatever. But again, you're just sort of like you're not really getting anywhere, because each stage of this process it involves something looking at something else, and you only ever explain seeing in terms of the eye that looks at the surface that is distinct from it. And once you sort of realize that, you see that this inverted image question is a kind of pseudo question, because the retina is not like a screen that something else is looking at. It's not there's no eye in the brain that looks at the image on the retina and then has to figure out whether it's inverted or not. It's the retina itself is doing the seeing. Obviously not on its own, in connection with all the different brain regions that are involved in visual perception. But the seeing is actually happening, in the retina and not, in something else that looks at the retina. And so this kind of immediate seeing, in the sense that it's not a seeing that is outside what is seen, this kind of immediate seeing is what he is referring to with this notion of an absolute surface. And for him, this is sort of what characterizes consciousness in general, and then in his sort of metaphysical extrapolation from that this is what characterizes structure, or these real forms in general. So an organism is also characterized by this absolute surface quality or nature, in the sense that the organism exists for itself. It's not sort of, there's no sort of external entity that has to observe the organism and see that it is structured in a certain way. The organism just sort of is its own structure. So yeah, in the case of the visual perception, you have looking at a letter or a word or whatever it is. Of course, when you read a text, you don't just sort of first see some dark regions within against a lighter background, and then sort of decipher what the letters are, and then join the letters together to make words, and then figure out what the words mean, etc. Like, this is someone who has to do that is not a sort of skilled reader. This is someone who is like maybe like a child who is first starting to learn how to read, has to do something like that. But an adult who has many years of reading behind them is not sort of deciphering the forms in that way. And it's actually interesting if you look at eye tracking studies. So you can let someone read a text on a screen and then have a camera that tracks the movements of their eyes as they're reading. We generally like fixate once for each word, unless it's like a long word that you have to sort of have two fixations for. But you just sort of bounce from the middle of each word to the next one, and so you're sort of seeing a word as like a unit, rather than sort of looking at each letter and then piecing them together to say, okay, it must be this word. And then it's also in our sort of normal reading habits, it's very hard to not see the word as the meaningful unit. And so like anyone who has like tried to proofread a text that they've written or that someone else has written, for example, you often read what should be there rather than what actually is there, and you miss typos or misspellings or whatever, because you sort of see what should be there, like the word that is supposed to be in this place in the sentence, rather than the word that is actually there in the sentence as written. So the sort of meaningful sentence, the sentence that should be there, is the one that is actually most sort of immediately given to us when we're reading. And then you have to sort of like resist the temptation or resist this sort of passage to the meaning, and sort of train yourself to see the actual text that is on the page, to be able to identify typos. And it requires a certain amount of training or experience of doing that before you can really be reliable at like copy editing. So yes, this is just a sort of another indication that what we're doing when we're perceiving is like we're sort of already on this plane of meaning, this sort of absolute surface of meaning, when we are sort of looking at the text, rather than sort of taking in a letter and combining that letter with another letter and then sort of deducing what the meaning is based on this sort of bottom-up construction process. Oh, and then maybe one last thing I'll mention here is that, so this last point where he talks about these like fill in the blank kind of things. So this is just sort of like the next step in this operation. So it's not just that we see the text written on the page and then sort of get to the meaning immediately, but you can also say like, if you have a word with a letter missing, you can often just sort of see, oh, that must be the letter W or whatever. Like you just see the correct word to fill in that blank. But then, of course, as he points out, a sequence of letters on a page, just as a certain like ink patterns on paper, doesn't have any sort of property of being incomplete and of producing the missing letter. It's only in the consciousness of the human who is reading that text, who is grasping this arrangement of ink on a piece of paper as a word with a missing letter, that it's only in that context that this letter is actually missing, that there's this sort of like immediate production of the letter that is missing. So yeah, the paper is just a sort of purely material substance in which one region of the paper that has ink in it and another region that doesn't have ink in it are completely independent of each other. Whereas the page, as seen by the person, is an absolute surface in which the space where the letter should be is like sort of calls out for that missing letter.
Yeah, I thought this section was really interesting. It made me think of structure of behavior. The in this, I think it's B2, where he talks about how absolute and conditional stimuli merely overlapping aren't sufficient for conditioning. The animal has to kind of grasp the sense of the coincidence of the stimuli in order for there to be I mean, at least on some level, in order for there to be genuine conditioning. This kind of makes me think of. I know that in training like a machine vision AI, you feed it images that have kind of like if you're training it to recognize dogs, for instance, you feed it a huge database of images that have been tagged, if I'm understanding correctly, as either images of dogs or as not images of dogs or as images of things other than dogs. And I wonder if Ruyer would say that the in the field of consciousness or like perception kind of does its own tagging, so to speak, for the living being, whereas that's heteronymous, I guess, or done by the engineer for the machine vision system in order that it can start picking out statistical irregularities among all of the images of dogs or whatever else it's being trained to recognize.
Yeah, that's a good point. I hadn't actually made that connection. Unfortunately, we have to sort of break off abruptly here because I have to head out and I'm getting picked up in a minute. But yeah, let's come back to this question about, yeah, so the type of training system you're describing is called supervised learning. And of course, supervised has this, like the sort of literal translation would be like overseeing something. So it's again, you can see that it's a very close connection with this, question about like the absolute surface versus the eye looking at the surface from outside. So yeah, let's come back to that next time. Yeah, so thanks everyone for coming out. I think we're going to move back to the regular time, so half an hour later than we started today. So it's 8 o'clock Eastern time for those in North America, but you can check the Discord event for the time in your local time zone.
That sounds good. Thanks, Nan. Thanks, everyone. Enjoy your event, Nan.
Yeah, thanks.